Key numbers, test intervals. One of the basically the two things you have to be worried about the entire section.
I was really tired last night, and I did my 3.1 homework instead of 2.7.
Instead of?
Yeah, because I thought that it was.
Well, 3.1 will be due just tomorrow, so just check tonight.
Okay.
But Michael, check it. It's on the video for today, 10:19. When you get it done, just go back and grade, okay? So you don't lose those points. Number 12, you guys already checking? You might have done this multiple ways. This is a crazy one. You were supposed to find the key numbers. Looking at the function, did you guys get the undefineds? +1 and -2. Then what did they do? They got common denominators, they did a nice huge fraction. They said, okay, set the top equal to 0 and the bottom equal to 0. They got all 4 by doing some extra work and getting common denominators. But what did I tell you guys was another way of solving it? Anyone get the other ones a different way than getting a common denominator? What was the original inequality, guys? You had x over x plus 2 minus 2 over x minus 1 equals 0. How else could you have done it without getting a common denominator? Yeah, go.
Probably x equals 2 times without common denominator.
Oh, okay, so the common denominator is what they did, so it was a great way. And the pitchfork idea? Set the top equal to 0 and the bottom equal to 0, got all 4 of the numbers. No one did the other one. It's okay if you didn't. In period 2, just because I know some of them did it the other way, you could have added this guy to the other side and then what? Yeah, you could have actually solved it. So the undefineds come from the denominators, and you could have actually solved it by cross multiplying, which would have been, I'm going fast, I'm distributing. You guys see I'm carrying the 2, and I'm distributing, carrying the x. You would have had to get everything to one side, right? How would you have finished? So I'm just showing you it could work multiple ways. You don't have to necessarily get all the common denominators, even though that is technically in calculus what I would show them to do. But you could have also added to the other side, cross-multiplied. You would have ended up with, you guys see the -4 and the +1? Factors equal to 0, each one must equal 0, so, dun, 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 dun. There's the last two. -1 and 4 come from the zeros, -2 and 1 come from the undefined. Okay. Doesn't mean you had to do it the common denominator way or the other way, just two alternate methods. Both ways work. Okay, sorry I paused there, but that was a tricky one, and if that had shown up in a homework problem, that would have been a little bit of a mess as far as solving. All right, we'll give check number 30. That was super basic in the sense of factor out a common factor, factor it all the way, find the zeros. Mark them in the number line test. True, keep it, false, ditch it. But just a few of you might have been confused when it said find the solution set and graph. Oh my, well that's fun. Let's get rid of that. The solution set, we wrote that down yesterday, but when they said graph, it just meant on the number line. Some of you thought you had to graph the whole function. That's not true. Is there another way of graphing on a number line without that? With the parentheses? Yeah, so you could have, at 3, done an open circle. Totally fine. I don't know. But what is the parentheses denoting or showing?
That it's not, doesn't sound like that.
Yeah, right, like an interval, right? The parentheses versus the bracket. So that way works, but so does this. Long story short, 3 to infinity was the only true portion. The other two are false. Let me give you a second on this one. He's kind of a mess. Let me zoom out just a little bit, though. Do you guys get it? -14 and -2 and 6 to infinity. Why are they all open? Yeah, it's not or equal to. And the undefined can't equal anyway, so that's open. And the inequality shows it's open also. A couple more seconds, get the right answers down. If you have questions, we can look at it. Number 66. Was this one of those domains? Do you see it?
Yeah.
Okay. Hold on. A couple more seconds. That's good. Mm-hmm. You guys should have seen each of these intervals. But it's okay if you closed it early. There should have been a closed bracket at 0 because what's the inequality? Yeah, greater than or equal to. So you were allowed to close at the 0, but why is the 3 still open? Why close it there and not there?
So you're fine, right?
Yeah, good. Undefined points, they can't be equal to. So the 0 is or is able to be equal to, should be equal to because of our inequality. So we close off the 0, but we can't close off the undefined. It's not part of the domain. Glad you made it.
What?
Glad you made it.
Thank
They
you.
were debating whether or not you would come.
Yeah. It's close.
You made it. Alright, any more even school kids? I think that's the last one. So Aiden, even answers are on the video. Check it out tonight. You can grade it up.
Okay.
Okay, did we get stuck? Any evens or odds? Calvin.
Number 73.
73. Okay, so we have an odd. You guys are able to check on Cal Chat. Let's go see what went wrong. But anything else? You're okay? Alright, was it better than you thought? Give me a thumbs up if you're like, not too bad. Give me a middle if it's like, thumbs down if it's bad. Okay, mostly middles. No bad. That's good. Alright. Let's go check out 73. Ooh, the fireworks one. I like this one. Okay, you guys at least saw the formula in the beginning when you were writing your directions and problems down, right? Let me get a picture of it if my computer will actually work one of these days. Now it's frozen. Okay. Just 73, Kelvin?
Yeah.
Okay. So we have our formula. Guys, just from what you wrote down, hopefully in homework, what's V sub naught? I apologize, that's physics talk. What's V sub 0? According to this. Initial velocity. So we could even label that if you wanted. You didn't even have to write all these words. You could have just drawn little arrows and said, okay, that's my initial velocity. And I think they give that to you, don't they?
Yeah.
Initial velocity of 160 feet per second. So we could say, when you're writing down your directions for your problems, 160. You could have actually labeled it instead of writing all the words. That's a great idea. To visualize. What's S sub naught? Or S sub 0, I apologize.
Initial height.
Good. Initial height, did they give you that in number 73? Okay, so when you were writing down the problem, you could have just written this and wait. Height is measured in what kind of units? They didn't tell it to you, but think logically. Feet. Good. Seconds is time. Feet is distance. Cool. Letter A says, at what instant will it be back at ground level? Well, hold on. We need an equation, don't we? So how can we plug this into our initial, or I should say, our original equation given to us for position? What's S equal to? And then plug in. Plug in. Oh, plus 0. Doesn't matter, right? What are the variables representing in this function? We have the independent t and the dependent s. Who's t or what is t? Time. Good. Gave it to us in the original, time in seconds. What's s? T is time, measured in seconds. But what is s? Height. If s sub 0 is, and then even back up here, the position equation where s represents height in feet. So when they ask us for letter A, I know it's a lot like physics, but it's okay. When they ask us when we'll be back at the ground, what do we know? Do we know the when, or do we know the where? The where. So where is it if it's on the ground? What's the height? 0. So can't I just set the whole thing equal to 0? That's all it is. And mathematically speaking, how do we solve a polynomial equal to 0? Oh, don't subtract. Factor. If you subtract, you'll miss one. Just mathematically speaking, factor, 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 right? Did anybody factor it already? What happens when you pull out the, what, negative 16t? What do you got? Nice. So if you set equal to 0, my zeros would be 0 and 10. What's the only one that makes sense for how long it took for the projectile to return to the ground?
10.
Good, because 0 is the beginning when it was fired from the ground. 10 seconds is when it returns to the ground. So final answer. Does this remind you guys of that football one from a few sections ago, like last chapter, the football punt? And it hit the ground when you had to make the position equal to 0? What's different with letter P? Okay, come on. That's just math speak. Or it can be translated into an expression. So height exceed 384. How do we put that in an expression? Greater than? Who's greater than 384? What variable?
-16.
True. But I would say before writing out the negative 16t squared plus 160t, isn't s the height? Wouldn't that be the strict translation? Whose height? S. Okay, cool. S has to be greater than 384. Then Grace, what did you do lifting s?
I put in the -16t squared plus 160t.
If I didn't let you use your calculator, what would be your next step?
Subtract
Subtract
the
the 384. Factor to get the zeros, make a number line, test, 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 like you did the rest of homework. But if I did let you use your calculator, what could you do? Graph the function. Now, question, what makes more sense to you? Graphing this guy and graphing 384 and seeing where he's above, or doing what Grace still said first and subtracting. What would be easier on the window and the zoom and all that jazz that you guys have to do? Would it be easier to try to find a height of 384 or to find a height of 0? 0 would be easier in the window, right? 384 we're going to have to zoom out and it's going to be annoying. Tell me. Yeah, you totally could if you want. But just to find the zeros, you still have to think your number line and key numbers.
Oh.
Does that make sense? So you could use the zeros. Or you could graph it and look for where it goes above 0. But I think actually 16 goes in pretty evenly, doesn't it? How many times does 16 go into 384? Grace, do you have it? Say it one more time.
24.
24. Thanks, Anne. And I think we took out a negative, so plus 24. So some of you are like, okay, I could use my graphing calculator, but maybe I've converted you a little bit. How hard is it to factor, and what factors of 24 that add to be negative 10?
Negative 64.
You don't have your calculator, do you? Minus 6, minus 4? Good. So we'd have to go ahead and make a quick little number line, throwing our negative 6 and our negative 4. Nope. Those are the factors. What would the zeros be?
6 and 4.
And then can we test, test, test? But if you want to be super snazzy and think logically about what's going on, technically we have to start our number line at 0 because there is no time passing before 0. That was the beginning. We know it hits the ground at 10. If you think logically, guys, if something's going up and coming back down, then it's going to be above 384. When does it make sense that it will be higher than 384? At the beginning, in the middle, or at the end? Because it's a downward parabola, so it's going to be the highest in the middle, right? So maybe you could cheat and not do all the testing. What's the final answer for those of you guys that got it? When will it exceed 384? Actually, between 4 and 6. Sorry, I wrote 5. Between 4 and 6 seconds. So those of you that said 5 seconds, yeah, at 5 it is higher, but what about 4.1? It's higher too. What about 4.7? It's higher also. Does that make sense? So it's all the times in between 4 and 6, but why did I make it open? It's not undefined.
It's greater than.
It needs to be greater than, not or equal to. It's asking when it's higher, not when it's at 384. Alright, that was kind of crazy. If I lost anybody in the process, you know where to find me during lunch, after school. But that was the only question that I had posed. Let's go back to notes, okay? Good job on that homework if we only got stuck on the word problem. And maybe after plugging in, you guys see the word problem isn't all that crazy. It's still just a quadratic with big numbers and something being chopped. Make makes it that much more exciting. Where are we at in notes, guys? Ooh, we're in chapter 3. Does anybody remember what I want you to think about for chapter 3 that might not make it quite as scary? Okay, it has logs, not that scares you, but hold on. Remember what I said yesterday? I want you to think of the whole chapter as a whole bunch of little tests. It's more fun than that, though. Puzzles. And puzzles have rules that we have to follow. So we just need to figure out what the rules are so we can solve our puzzles. So, yesterday we did not get very far, sadly. But today we're going to rock it out. We got down a super general exponential function. I didn't even mention this yesterday because we were going so fast because we had finished 2.7 trying to get into 3.1 to catch up. But have you ever heard like a speaker say exponential growth or growing exponentially?
Yes.
You know what they're talking about? Are they really talking about some table and some math and they're actually thinking of like this exact curve? No. What they're trying to say is it's growing faster and faster and faster and faster. Kind of like it's a problem that's compounding. If we were to go into like business speak. But anyway, we got down the curve and we saw that the curve gets super steep, super fast. And as you go into calculus and talk about slopes, I'm like, the slope is always getting higher, but that's a little too advanced. Did we talk about how to plug this into our calculator?
Yes.
Sweet. Did it work out all right?
Yeah.
What button are we using?
Raise.
Okay. The raised to the power of the caret button. This is the page we didn't get to finish, so check where you are. Why did I choose 2 to the x as the most basic base to start with?
Because 1 always.
Yeah, 1's the same as boring. 0. They're not even exponential because 1 to any power is 1, 0 to any power is 0. Maybe I could have chosen like 1.1, but that's kind of gross. We chose the next nice number 2. We used our 3 clue points we talked about yesterday. The intercept, 2 to, well, any base to the 0 power is 1. Any base to the 1 power is itself, and any base to the negative 1 power. That was the weird one, but remember that's the reciprocal, negative exponents. We're reviewing some stuff. I think we got down domain and range, but we hadn't filled in the y-intercept yet. I think that's where you guys are. Strictly monotonic. If it hasn't been flipped, reflected, it's strictly increasing, and like we talked about exponential, growing exponentially, it's increasing, it's going really steep, really fast. As you go to the right, but as you go to the left, it's getting closer and closer to the horizontal asymptote. If you fill that one in, y equals 0, we already talked about this last chapter. And so the key parts to any exponential graph, the intercept, the swoop, there it is, and then the horizontal asymptote. But I just gave these 2 little points to help you out with how steep to make that swoop. I think it makes it easier. And it reminds you of negative exponents at the same time. Now, if I'm calling this a parent function, what am I getting ready for? Yeah, I'm getting ready for transformations. So, remind me real quick, what are some different ways that we can transform functions from, I don't know, last chapter, chapter before? Shifts. What's a snazzy math term for shift? No, those are different. Translations, okay. So shifts, translations. Now flips. What's the snazzy name for flips? Reflections, and then what's the third one? Dilation, stretch, and compress. Okay. I have kind of a setup for them. But let's go ahead and see if we can do it before we talk about how they happen. Let's see if we can just do it. So, kiddos, my f of x is going to be my parent function. Non-transformed. Plain old 2 to the x. And be careful when you're writing these. I've seen multiple people this year and in years past that write the x too big and they get confused. Make it an exponent. Make it a superscript if we were talking in computer language. And you just saw it a second ago. How do we get 2 to the x on the graph? We just put it down. What are some important pieces that we need?
1.
Good, 0, 1. We have the intercept. What's another important piece to build this function? 2. What do you mean? I heard 2 and 1. What order do they go? When x is 2, y is 1?
1 is linked to 2, right?
Yeah, when x is 1, y is 2. Does that make sense? Plug in, x is the first power. So we do have the point 1, 2. I had a third point just because I thought it was helpful. What else?
-1.
Good. Negative power makes it the reciprocal. There's one more important piece.
-2.
I think we have enough points. Is there any other characteristic of the graph that would help us? The horizontal asymptote. We could do more points. Anna, I think, was going to keep going. That's totally fine. We could get the next one. When x is 2, y is 4, we could keep on going to the right or to the left. But I think the asymptote just kind of tells us what direction to go. Here's our f. So if you have colors, that's awesome. You might want to, if you don't have colors, go dotted, go bold.
Put that for that graph.
So we have f of x's graph. What's changed with g? Tell me verbally first before we go
It's
graphing.
a 3, and it's a +3.
Good. It's on the outside. It is an addition, so we are going to be going vertically. Ooh, outside.
Oh, yeah.
The y's get shifted. In which direction? Okay, so this is going to be a shift up 3. Now, guys, look at the graph. How are we going to shift this up 3? What's something we're going to move?
Oh, each of the.
Okay, each of the points, can we just go straight up?
Yeah.
Okay, so let me get a few y values up here. So I can shift 1, 2, 3. Got it. I can shift 1, 2, 3. Got it. I can shift now. This is at a half. So 1, 2, 3.
2.5.
We can actually label all those points, right? It'd be 0, 4. You're just adding 3 to the y values. You have 0, 4. Adding 3 to the y values. 1, 5. Adding 3 to the y values. Didn't even label that one. -1n. That's 0.5. 3.5. Good question. What would be something else that's good to shift besides the points? Yeah, the horizontal asymptote. Because it will help us with our graph as well. True? So you're not always shifting points. Sometimes you're shifting other characteristics too, like vertical asymptotes, horizontal asymptotes, et cetera, et cetera. Technically, the shape should be exactly the same to shift it up. So I apologize, mine's not exactly the same, but it's close. That's what we call a rigid transformation. Holding the same shape, just in a different location. But guys, what's going on with H? Tell me verbally what's going on. How do you know it's a reflection? What do you see that tells you that?
Negative.
Multiplying by a negative. Ooh, on the outside and the inside? So how many reflections?
Reflection of the x-axis.
Good. And?
Y.
Uh-huh. So we could put it in a snazzy way. Reflection in the x and y axis. However, what's like the simple way of saying
Flip up.
flipped up and down, vertical flip and good. I don't know about you guys, but that just makes more sense in my mind. But it's good to have the terminology.
Wait, if it's horizontal, wouldn't it be in the circle?
Huh?
Because it isn't horizontal.
Horizontal is going to be a reflection of the y-axis. It's flipping across the y. What's on the right, it's on the left, it's on the left, it's on the right. And then vertical is going to be flipping in the x-axis. So technically the order, oh, that's right. Vertical in the x, horizontal in the y. To do 2 flips, we kind of have to do one at a time, right? So which one do you want? Which one do you guys want to do first? Vertical, then horizontal?
Vertical.
Sure. So what do we do with vertical? We take all the y's and flip the sign. So instead of having 0 positive 1, it's going to be 0.
Negative.
Instead of being 1 positive 2, instead of being -1, 1/2, -1/2. But if I was to catch it right now, I've only done what flip?
Vertical.
Wait. How do I flip the horizontal asymptote?
Oh,
Take first.
Can I flip it?
isn't it 0?
It's here.
Yeah, 0 flipped is still 0, so it doesn't matter. But just in case, I was ready. I'm not done yet. That was a vertical flip. Now what? So you'll just flip the signs of the y's. What else would flip the signs of?
There.
So instead of a positive 1, well, I guess you could have just said -1, -2. Well, either way, it does end up being in that spot. 0, 1, 0 times a negative is still 0, so he's established. And then -1, -0.5, and +1, -0.5. So we could have flipped the x's and y's all at the same time. Or we could do it like in a step-by-step progression. So we have our g. Oh, this is our g. We have our g, and we have our h. Do our old tricks work? For translations, for reflections, what's the one thing we didn't really do?
Translations.
Well, that's weird. Why didn't we do them? Well, let's pause for a second. Because actually all I have on this page are translations and reflections also. We'll talk about why dilations didn't really show up. Not that it can't show up. It just didn't really show up. As we saw on the page before, B, adding on the outside is still just going to be a vertical shift. What we didn't have an example for, but should hopefully have this. Subtracting C is going to be a horizontal shift. And I just put the minus in there to remind you it's always backwards of what you think whenever you're dealing with horizontal transformations. Maybe backwards isn't the right word. Different than you would think. Sometimes it's the reciprocal and sometimes it's literally the opposite. A is just the base. If you guys wouldn't mind, skip a quick little line. I'll come back to that in a second when I can get your focus again. I'm going to give you a little quick note about the base. I'm putting the easy ways of talking about the reflections as far as the vertical flip, horizontal flip. Put the right axis. Let me give you a second. Get down what you need. But you guys were able to graph them just a second ago without really stressing too much about the actual formulas because of all the work that we've done on them. So this page isn't so much to stress you out, it's more to just remind you where these transformations will show up. Now, as you guys get there, once you get down to the reflection, remind me what kind of math is going on, what kind of operation is being included to get the flips. You need to look at the example for H. What was going on? Yeah. Good, the negatives that got multiplied in, right? So we could have, for a vertical flip, it will be a negative on the outside. So you'll have something like g of x is equal to negative a to the x. That could be one example. A negative on the outside of the exponent. Whereas if you want a horizontal flip, that would be, with the argument. And now to add that quick little note about the base. We were graphing 2 to the x, right? So when we go over 1, we go up 2. What if we were graphing 4 to the x? What would be that next point when x is 1? 4. What if it was 8 to the x? At 1, it would be at 8. What happens as the base gets bigger? The graph gets taller, slimmer, steeper. Does that make sense? So let's write that as our note. As the base increases, the graph stretches vertically. So this is kind of why I didn't do a dilation, because if they wanted it to be steeper, they probably would just have a higher base. Or if they want it to be less steep, they'd probably just have a lower base. Like if you were to go from 2 to 1/2 to 1/4 to 1/8, that's going to be getting shrunk vertically. So not that dilations can't show up, not that you can't have like multiplication on the inside or on the outside that would be a dilation, and we'll keep our eyes open in case it does show up. But usually just the bases change when they're trying to do that sort of shift or that sort of change to the graph. All right. We talked about graphs. There's only one thing left to do. Let's talk about equations. We talked about graphs. One thing left to do. Let's talk about equations. This property is a big one. It's not the only one, but it's a big one. It can be tricky and yet, oh, it can be so nice. Give you a second to write it down. You might want to put a little star by it, especially if you're a highlighting kind of person. The one-to-one property of exponential functions. I'm going to put in parentheses the word ignore. This property allows us to ignore the bases, but only if the bases match. If the bases don't match, all bets are off. We can't use the property, and there are other ways to solve it. It would just be for a future section once we talk about logarithms. But if the bases match, we can ignore them and get to just the exponents. We can make this huge jump where we go from having exponential pieces to just having an equation dealing with the exponents themselves. But the dilemma is, if you guys look down below at these examples, and these are the ones I put on the whiteboards and had the Precalc period 2 kids pass down. I had them all solved and I said, here, check it out. Ask me questions if you don't get it. And I walked with the whiteboard. Do the bases match? No. This is 2 to the 2x and this is 64 to the 1. Well, this is dumb. It doesn't even work. Can you break 64 down? Yeah. Is he a perfect power of something, possibly? Yeah. Could we do the factoring tree? Sure. It gets kind of annoying after a while. I like doing the division boxes. Except it should go inside. Okay. Does 2 go into 64? The answer is yes. How many times? 32. Does 2 go into that? Yes. How many times? 16. 2 go into that? Yes. 8. 2 go into that? Yes. 4. 2 go into that? Yes. 2. Woo! How many 2s? I can rewrite 64 as 2 to the 6. Why is that good? Bases match. And if the bases match, what can I jump to? Ignoring the bases entirely and just looking at their exponents. Is that a magical jump? Nope, I used the one-to-one property. And what did I use it to let me do? Ignore. I didn't cancel out. I just am able to ignore the base and say, hey, sweet. So 2x must equal 6. Hence, x equals 3. Divide by 2. And we're done. Dun, 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 dun. The answer is 3. So, does that inspire you on number 2 to try to get the bases to match? Mm-hmm. Are you already thinking about 125? Yeah. Think he can get broken down? Anybody figure out what he can get broken down to be? Good. I'm going to work it out step by step, but someone already said 5 cubed is 125, and they're right. I'm going to rewrite this then as 1 over 5 cubed. But Trevor brought up a good point. He said something about a negative exponent. Why did he go to a negative exponent?
When you put 1.
When you have 1 over, it can be rewritten as a negative exponent. Why does that make all the difference?
Oh, basic
X minus
function.
equals -3.
Ooh, yeah. Go. The faces match. 1-to-1 property says ignore the 5s. But we had to get them in the same place. We had to get them, before it was 1/5 cubed. That's not helpful. But 5 is a -3. Now it fits my property. I can say x minus 2 equals -3. You guys already solved? What's x equal?
-5.
Ooh, careful, plus 2.
Oh.
Okay, it's so easy to do. To see them and put them together.
I added.
Several of you, yeah, right? Because you saw them just put them together. Several of you have done that this year. Just watch out. Algebra is easy, but you still have to go step by step. So, how could this get crazy hard? Well, these are already kind of complicated because it didn't match to begin with. We had to make them match. And the 1/25, that was tricky. What else could happen? Well, they could bring in the most natural exponential base ever.
Oh.
E. All you guys are groaning. E. He's the most natural exponential base ever. He happens in business with compounding interest. He happens in science with population growth and decay, even radioactive element growth and decay. He happens in econ, well, it's kind of the same business principle. He shows up all over the place in natural applications, so we have to talk about him. His name is the natural number, that kind of helps a little bit. E is called the natural number, and he is approximately 2.718282828. So that's not necessarily something I need you to memorize per se, but to know that he's 2.7-ish. He's 2.7-ish. But my question to you is, just because he shows up, I just need you to know he's a number, but otherwise, is he really going to make things all that much harder in these types of problems? Yeah, he's still a base, and well, he's still match. So what are we still able to do, even though there's need?
Just put 3x plus 2 equals 3.
Got it. If he shows up, don't be scared. Just do what you know how to do, even though he's not written as most numbers that you're used to. Whatever. Bases match. Ignore the e's. Cool. Solve. Good. And subtract the 2. 3x equals 1. Solve. How could they make it a little bit trickier? What's going on in number 4? I'm going to have a quadratic. But with quadratics, hopefully we are getting to the point where we're getting better and better at looking at them and saying, oh, get them all to one side and then back. Now, this one's not crazy hard. You don't have to multiply A times C and do grouping. You can jump to the answer, but don't forget how to do the harder ones too. Oops. It's not 6, that's 0.
What?
Multiplies to be 6 and adds to be -5.
No, -2.
6 times -1 is -6. I need a negative times a negative. I need a -2 plus a -3. Tricky. 6 is always a messy. So what are our 2 answers?
2 and
Got it. Dun, 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 dun. How hard does this section look, guys? Oh, it looks nasty. Maybe the graphs will be a little nasty, but don't you just get the parent function and move it the way you need to? Use those representative points that we talked about. The intercept when x is 1, x is -1, and the horizontal asymptote. You might be using your calculator just a little bit, but otherwise use that 1-to-1 property as best you can. Let's go ahead. Ooh. I'm going to have you write down homework in just a second in your spiral. I'll put it on the screen in case you haven't started it. But first, we have one last example. Life just got exciting. What do we do? Multiply? I mean, we could multiply by the 9, or we could divide the 2. Which one looks more helpful getting excellent?
Divide by 2.
Okay. We divide by 2. Some of you are going to do it in a way that hurts your brain. I'm going to do it by 1/2. That is going to get rid of the 2 over here. And isn't that going to be nicer when I come over here? Just to multiply by 1 half. Just a little nicer on your brain. You get 3 to the 1 minus x equals, what do we got on the right hand side? 2 over 18, which reduces to be 1 over 9. You're allowed to use your groups. Finish the problem. Go. Work on your own. You're allowed to reach out to your groups once you think you have an answer or if you get stuck. You guys got it? So what'd you do to 9?
We put 3 squared.
Good. But you didn't want to keep it down, so you should make it 3 to the negative 2, right? Because it's 1 over 3 squared, which is 3 to the negative 2. Then you just keep going.
1 minus x equals negative 2.
Ignore the bases because they match, and you can solve by
3.
counting the 1. And some of you have already gotten there, because negative x equals negative 3, x equals 3. Baby puzzles, can you do it right? I think so. Just go carefully. Keep it legal. And let's go ahead and write down this homework. If you guys don't have it yet, Spirals open section 8.1. Here we go. Homework number, where are we on? 18? Homework number 18, section 3.1. The problems should be showing up right about there. Every now and then I throw in an extra credit problem. It'll just count the same as a normal problem, but it's less.